Okay, so today we are going to be working on a 5th grade math lesson that has to do with dividing fractions. So to start off, we have our problem, our word problem. And it reads, there's one pizza for a class party. If the pizza is cut into equal sized pieces of 1/4, how many students will get pizza? So we're going to make sure to write our problem down so we can refer back to it throughout the lesson. So it said there's one pizza, and they're going to be cutting it into equal sized pieces. So we know that means that they're going to be dividing it into pieces of size 1/4. And we're looking for how many students will get pizza. Okay, so we're going to set that to the side just so we know we can refer back to it throughout the process. So to begin, when you're discussing fractions, you always have to relate the problem back to the parts of a whole definition. And so the parts of a whole definition states that A over B of a whole indicates that a whole has been partitioned into B equal sized parts, and A of those parts are being considered. So what all those words mean, that whenever we are transferring it into operations, so in our case, division, when we divide and we're looking at our parts of a whole, this is going to be where our 1/4 fraction comes into play. So B is going to be the equal sized parts, which in our problem is represented by 4. So we know that we're going to be dividing that one pizza into 4 equal sized parts. And A is the number of parts that is being considered of those equal sized parts. So we know that that's 1. So out of our pizza that's going to be divided into 4 equal sized parts, we're going to be focusing on just one of those 4 equal sized parts. So to begin, we're going to be using 2 different models. So the first model that we're going to be using is the linear model. So the linear model, when using this, you want to emphasize distance. That's the main attribute that really needs to be focused on whenever you're working with the linear model. And so we're going to be using our fraction tiles to show equal lengths of distance. So we have that this is 1. So this 1 fraction tile is going to represent our 1 pizza that we started with for the class party. And so because we're working with distance, we're going to make sure and we're going to mark at each end. And we're going to label, the first mark is going to be 0, and we know that our whole is 1, so we're going to mark that second mark as 1. So we can see that this is now a distance from 0 to 1. So we are going to be working with parts size 1/4. So we're going to grab our 1/4 fraction tiles. And whenever you use fraction tiles, you want to make sure that the students understand that because they cover the same amount of distance in the linear model, then that's how you know how many pieces are going to go into it. So we can, whenever we line them up, we can see that indeed these are 1/4 size pieces because they cover the same amount of distance as that one whole does. So when we are trying to figure out how many size pieces 1/4 will cover the same amount of distance as the one whole does, we're going to line up starting at our 0. We're going to make sure we're real precise in butting them up on the exact edge and where we made that mark. And we can now see that 4 lengths size 1/4 will cover the same amount of distance and the same amount of equal lengths as that size 1 whole, because distance and length is the main attribute. So you always want to relate it back to the length. So when looking back at our problem, using the linear model, we saw that 1 divided by 1/4, if you count how many 1/4 tiles we have, 1, 2, 3, 4, equals 4. This is also where we can make a connection, and we can see that division and subtraction are interrelated, because division is essentially repeated subtraction. Because when you subtract X amount of times, or when you subtract like X amount, Y amount of times, you're actually going to be like partitioning it and taking it away. So for instance, when we're dividing the 1 by 1/4, you can actually take them away and see that it's 1 1/4, 2 1/4, 3 1/4, 4 1/4. And so that will take it away and bring you back to that distance of 0. And so we see that division is repeated subtraction. So now we're going to clear our boards because we're going to be switching to use the area model. So for the area model, our main attribute is going to be area. So we want to make sure that we're covering the same amount of surface as our whole. And that's how we're going to figure out how many pieces fit into our whole. So we're going to use this blue circle to represent our whole, or our one pizza. That was what the class started with at their party. And then to prove that these yellow pieces are size 1/4, we're just going to line them up right on top of that one whole to show that it covers the same amount of area. And so now, since they are size 1/4, we're able to count how many pieces size 1/4 cover the same amount of area as that one piece size 1 whole. And so we can see that it's 1, 2, 3, 4 pieces size 1/4 cover the same amount of area as the one whole did. So again, 1 divided by 1/4 equals 4. And this is where we can make the connection between inverse relationships between whole numbers and rational numbers. So this is where students might also get confused, because you can say that when you divide whole numbers, you start with a larger number and you end with a smaller number than your whole was. And that kind of makes sense because you're dividing it or you're partitioning it. But whenever you divide a rational number, you will end up with a larger number than your whole was. And that's seen through this. So we started with 1, which is not a very big number. And then when we divided by 1/4, we ended with 4, which 4 is a larger number than 1. But it's because we are trying to see how many pieces size 1/4 fit into it. So you're counting the size of the pieces rather than the size of the whole. And that's why you have that inverse relationship between rational numbers and whole numbers. And so that was our 5th grade lesson over dividing fractions.